Bismillahirrahmanirrahim. I'm Ahmad Noman SADIQ. Our today's topic of discussion is resolution of a vector. So first of all, meanings of resolution of a vector. Resolution means to resolve a vector, to convert a vector, to split a vector, or to divide a vector into its components. But here today we will discuss the special components. We will divide or resolve a vector into the special components, and those components are called as rectangular components. It means we are discussing today the resolution of a vector into its rectangular components. So first of all, you must know what is a rectangular component, or if we have a vector and we want to resolve that vector into its rectangular components, so what are the rectangular components? So rectangular components means those components are those parts of the vector which have an angle of 90 between them. So suppose one component is this one and the other component is this one. And if there is an angle of 90 between these two vectors, then we can say these two components or these two vectors are rectangular components of a vector. So simply, if two components are perpendicular to each other, if those two components are orthogonal, that is, if they have an angle of 90 between them, then we can say that those components are rectangular components of that vector. Now, the next step is how to resolve a vector into its rectangular components. For that, suppose we have a y-axis here and x-axis here, and we have a vector f. It is the vector of force making an angle theta with x-axis. So this is the vector. We want to resolve this vector into its rectangular components. That is, we want to resolve this vector into two parts which must have an angle of 90 between them. So what must be the procedure? So for that, we resolve or we draw a perpendicular from this point over x-axis. So I am drawing this line, and this line is actually the perpendicular from this point over x-axis. What does it mean? Perpendicular means this line must have an angle of 90. So there should be a 90-degree angle between this line and x-axis. So actually I have divided this side into two sides which have an angle of 90 between them. And now it is very obvious that it is a right angle triangle because one angle of this triangle is 90 degrees. Now, but we are talking about vector resolution. So for that, it is a vector and these two are just the sides. These two are just the sides, not the vector. So we will convert these sides into the vectors. So how can we convert the sides into the vectors? Just by putting an arrowhead. I will put an arrowhead here and an arrowhead here in such a way that these, actually I have made this as a vector and I have made this as a vector, and it is obeying the head to tail rule because head of first vector is joined with the tail of the second vector, and this is the resultant vector. Head of the resultant vector is joined with the head of last vector. The second vector is the last vector, and tail of the resultant vector is joined with the tail of the first vector. So actually I have resolved, I have splitted, I have converted this vector into two parts. One part is along x-axis and the other part is along y-axis. So the component, this is one component, this is the other component. So this component which is along x-axis, it is the component of f along x-axis. So it will be called as fx, the component of f along x-axis, and it will be called as component of f along y-axis. So it will be called as fy. So f is actually the combined effect of fx and fy, because this is the resultant vector, and you know what is resultant vector? The combined effect of all the vectors added together to get a single vector. So we have added fx and f2, if we add fx and fy, then we will definitely get this f. And it is not a simple addition. It is actually, I am talking about the combined effect, not mathematical addition. So f is the combined effect of fx and fy. So I can say that f vector, it will be equal to fx plus fy. Again, I will say that this is not mathematical addition. I am talking about the combined effect. This is just the combined effect of these two vectors. It is equal to this one. Now, our next step is to find its value. So, you know, a vector has two things. One is its magnitude and the other is its direction. So, fx, it has a magnitude equal to fx. So, its magnitude will be represented by fx. But what about its direction? So, its direction is very obvious. So, you know that it is towards x-axis. So, we can say the magnitude is fx and the component of this vector is along x-axis. So, its direction is along x-axis. So, there is a vector which represents a direction along x-axis, and that vector is called as I unit vector. Actually, this I unit vector has a magnitude equal to 1, but its direction is towards x-axis. When 1 is multiplied with fx, it will remain fx, and actually this unit vector is representing the direction. So we can say that fxi, this is fx, it is actually representing the x component of this vector f. So its magnitude is fx and direction is I. Similarly, we can represent fy in this way, fy into j unit vector. So j is also a unit vector which is actually representing the direction, and the direction of j is always towards y-axis. So it is also a unit vector which has a magnitude equal to 1. 1 will be multiplied by fy, it will remain fy, and ultimately or practically we can say j is representing the direction towards y-axis. So we can simply write fyj. So we have converted a vector f into two parts, fx and fy, and we know that one component and the other component have an angle of 90 between them, because the angle between x-axis and y-axis is 90 degree. Now I can say, or I can write it as f is equal to fx plus fy. So fx can be replaced by fxi and here fyj. Our next step is to find, actually we have converted a vector into two components, fxi and fyj. So here we have already found I, that is the direction of one component, the j, the direction of the second component, but we have not found fx, the magnitude of this component, fy, the magnitude of this vector. So our next step is to find the magnitude of fx and fy. So how can we find the magnitude of fx and fy? For that, we simply consider a right angle triangle without mentioning the direction. So this part, this side of right angle triangle, you know, is called as hypotenuse. And if this is the angle, this is theta, then this side will be called as base of the right angle triangle, and this side is called as perpendicular. So we can name this right angle triangle as ABC, and this was F and this side was represented by fx and this was represented by fy. So now I am not considering the direction because we know already this direction is I and this direction is j. So I am just trying to find out the value of fx and the value of fy. So what will happen, you must keep in mind that we know this value because this was actually the vector and I want to resolve that vector into its component. It means I know this value and I know this value. With the help of these two values, I would be able to determine fy and fx, that is the magnitude of fx and fy. So how can we do that? Actually, if there is a right angle triangle, because there is a 90 degree here, there is a trigonometric ratio. So first of all, I will try to find out fx. So I know that there is a relationship between fx, theta and f, that is base, theta and hypotenuse, and this is a trigonometric ratio, and this is very famous trigonometric ratio and it is called as cos theta. So for the time being, this is not my topic to explain the trigonometric ratio, I am just using it. So cos theta will be equal to fx over f. It is actually, the formula is base over hypotenuse. It is cos theta. So actually I have to find fx. So fx, how can I find the fx? This f will go here. So it will become f cos of theta. So the value of fx, the magnitude of fx can be determined with the help of this formula. And we know the value of f, we know the value of theta. So if you put the value of theta here, simply take the cos of that angle and ultimately if you multiply it with f, you will be able to determine the value of fx. So in this way, the magnitude of fx you have obtained. Similarly, you can find out the value of fy. So how can you find out the value of fy? There is also a relationship between perpendicular and hypotenuse. And the relationship is, there is a relationship between perpendicular, hypotenuse and theta. That is called as sine of theta. And sine of theta is fy, that is perpendicular over hypotenuse. So from here, you can find out the value of fy. So fy will be equal to, it will go here, so f sine of theta. You know the value of theta, you will take the sine of theta, multiply it by f, and then you will be able to get the value of fy. So in this way, you have obtained the value of fx and fy, which were actually the magnitude of these two vectors. So fx is actually equal to f cos of theta. So fy will be equal to f sine of theta. Now, if I want to represent this vector and I want to show its vectorial form, so how can I write that? So f in vector will be fx. So fx is actually can be replaced by fx into I, unit vector. It is magnitude, its direction, and fy into j. Now I know the value of fx, I know the value of fy. Just put the values f cos theta I and here f sine theta j. So now this is complete resolution of a vector into two components which have an angle of 90 between them. We have found the magnitude of those two vectors. We have also found the direction of those two vectors. So this was resolution of a vector into its rectangular components. Now there is an extension. Extension of this topic is, actually this was to resolve. If this was the vector and I have resolved it into two components which are perpendicular to each other. So this was known to me, angle was known to me, and I have found these two components. Extension is, if if I know these values, fx and fy, and I want to determine these two values, f and theta, so how can I do that? So this is extension. So how can I do that? For that, suppose a right angle triangle, and fx, the magnitude of x component, is given. Fy, the magnitude of y component, is also given. But you have to find out this theta, and you have to find out this resultant vector, this the value of hypotenuse. Actually, one more thing I must explain here. Theta is actually representing the direction of the vector. So how can it be explained? Actually, some people or some students consider that directions are only east, west, north and south. This is not the case only. Actually, this theta is also representing the direction. So I will explain it like this. So if theta is this, if I change the theta, suppose the theta is larger, then you are seeing that the direction has been changed. With the change of theta, the direction is being changed. If I change the theta in this way, so theta is smaller, the direction is this one. Smaller, the direction is changed. Larger, the direction is changed. So with the change of this theta, I can change the direction. So theta is actually representing the direction of this side, if this is a vector. So it means I have a right angle triangle. If I would be able to find the value of this vector, that is the magnitude of this vector, and this theta, then actually I have found the value of this vector if I consider it as a vector. Now how can I do that? First of all, I will simply ignore the vectors, ignore the directions. So this is theta, and I can say here it is f, it is fy, and if it is fx. So it is right angle triangle. If you know the base, if you know the value of perpendicular, then you would be able to determine the value of hypotenuse. So how can you do that? A very famous theorem, which is Pythagoras theorem or Pythagoras theorem. And what is that? The theorem is, you just take the square of base, square of perpendicular, then you will have to add those two squares and simply take the square root, and then you would be able to find the value or magnitude of this hypotenuse. So if you know the value of this one, you know the value of this one, you would be able to determine the value of the magnitude of this hypotenuse. Now next step is to find the value of theta, which is actually the direction of this force, the direction of this vector, if I consider it as a vector. Then how can I find the theta? Actually, with the help of this and this, because we have the known values of fx and fy only. So with the help of these two values, we would be able to determine the value of theta. So how can we do that? There is also a trigonometric ratio between these three quantities, and that is tangent theta. Tangent theta is equal to perpendicular over base. So you know the value of fy, you know the value of fx. So in this way, you would be able to determine the value of tangent theta. So if you know the value of tangent theta, then you can also find the value of theta, because you will simply put theta in a calculator and take the inverse of tangent. So taking the inverse of tangent of this theta, you would be able to find the value of theta. So actually you are trying to find out about this value, for which value of theta, if we take the tangent of that theta, we will get this value. So in this way, you would be able to determine the value of theta. So theta means you have determined the value of direction. So in this way, you have obtained the magnitude of the vector and direction, actually the resultant vector. So we have actually, what we have done today, we have resolved a vector into its rectangular components, and then at the end, if we know the rectangular components, we would be able to determine its resultant vector. So we have discussed both the cases. Thank you very much.